Hello everyone. I'll be covering the topic of functions over the next three lectures. The topic for today's lecture is using functions. We've already learnt about the print function, which enables us to display output onto the screen. In today's lecture, we are going to learn about the input function, which will enable us to obtain user input via the keyboard. I'm going to introduce you to a lot of terminology with respect to functions. Today's lecture is going to be demo heavy. Closer to the last part of today's lecture, we are going to make a fun battleship game. The reading for this particular topic is chapter 3 from Downey book. Please make sure to go through that. I'm going to kick off today's lecture by going through a fun guessing game. I have Jupyter Notebook session open here. We are going to guess what exactly function f is doing. Function f takes one input which is stored inside the variable x. It produces one output which is stored inside the variable y. I'm going to go through a series of inputs to the function f and I'll be showing you the corresponding outputs. Then I'm going to ask you to guess what the function f is doing. As you can see, when x is 0, f of x is 1. When x is 1, f of x is 0. When x is minus 1, f of x is 2. When x is 2, f of x is minus 7. When x is minus 2, f of x is 9. When x is 3, f of x is minus 26. When x is minus 3, f of x is 28. When x is 5, f of x is minus 124. When x is minus 5, f of x is 126. Are you able to see a pattern here? Please pause the lecture video here and write a comment in the comment section stating what do you think function f is doing. If your guess was that it is computing 1 minus x cubed, then you had the correct answer to my question. Whenever you're trying to understand a function which you did not write, the best way for you to understand the function is by going through a set of inputs, observe the corresponding outputs, then try to make a guess as to what that particular function is doing. Finally, verify your guess by trying a couple of inputs. Let's try input of 10. That's supposed to give us minus 999. That seems to be the case. An input of minus 10 would give us 1001. I'm going to scroll the notebook all the way to the top and I'm going to ask you another question. What do you think will be the output of this particular cell when I run it? Given that f of x is 1 minus x cubed, one might guess that the output of the cell would be 1. But that's not the case here. We got 1001. Pay close attention to the input cell number within the square brackets over here. The input cell number for the previous cell is 2, whereas the current one is 14. So the x variable's value that is going to come into this cell's execution will be from the previous cell. So if I scroll all the way down, you'll notice that in input cell 13, I have a value of minus 10 assigned to the variable x. That is why you're seeing the output of this particular cell as 1001. It is very important for all of you to go through kernel restart and run all on your project notebook file before you run the autograder test.py script. Sometimes you'll notice that your notebook file contains the correct answer to a particular question, but test.py fails for that particular question. The majority of the times, the reason for that would be because you did not go through the kernel restart run all step before running the autograder test.py script. Test.py automatically goes through the kernel restart run all for your notebook file. I'm going to Make sure that I click on kernel restart run all now. Now observe that input cell 3 produces an output of 1, assuming that x variable has an assigned value of 0. Do remember to go through kernel restart and run all before you run your autograded test.py script. I'm going to switch to my slide deck and let's talk about the pseudocode lecture example for functions. Recall that one of the problems in the pseudocode worksheet introduced you to the concept of functions. We had two snippets of code, which were main code and move code. Move code here is an example of a function. In today's lecture, we are going to learn all about using functions. That would be step 2 and step 5 in main code. How exactly can we use functions? We'll be calling or invoking the function. While we are doing that, we'll be learning about how to pass arguments into parameters for the particular function call. What exactly are parameters? Parameters are special variables which are included as part of the function definition. What are arguments? Arguments are the values that go into the parameters. An example of an argument would be 2 here. An example of a parameter would be the moves box here. We'll also learn how to ask functions specific questions and how to get answers from them. We just went through an example function f, which produces some kind of an output. We are going to learn how to use the output, which is something which is called as return value from a function. In the next lecture, we are going to learn how to write our own functions. Let me get started by introducing you to a lot of terminology about functions. Pay close attention to this image at the bottom of the slide here. Notice that we have two blue blocks of code which are copy pasted code. In the world of programming, copy pasting code is always a red flag. I'm going to introduce you to a term called refactor. The term refactor refers to the fact that a programmer takes an existing program and reorganizes the code in such a way that we can avoid repetition or redundancy. How can we perform refactoring? We can do that by using functions which will enable us to make the program more concise and precise. In the world of functions, we are going to have to deal with inputs and outputs. Let me give you an analogy for you here. I'm sure that all of us consider ourselves to be good drivers. If I ask all of you the following question, which is, how many of you know the internals of a car really well? I'm quite sure that most of you would answer no to that question. That's because we don't really need to know how exactly a product works in order to be able to use it well, correct? All that we need to know is what would be the inputs to the product and what sort of outputs would the product produce corresponding to those inputs. For example, you need to know that when you press the gas pedal in the car, your car will move faster. You also need to know that when you press the brake pedal in the car will slow down or come to a stop. That is all that is needed for you to become a good driver. Inputs and outputs are going to be the essential part that you need to focus on with respect to using functions. Let's talk about inputs to a function. Inputs to a function are going to be called as parameters, which are special variables that are included as part of the function definition. Examples of parameters here are param1 and param2. What is an argument? Argument is the value that is sent to the parameter while calling or invoking the function. The arguments line up with the parameters. Example here would be argument 1, which is arg1 lining up with param1 and arg2 lining up with param2. A lot of people confuse both of these terminology together. They are not interchangeable. Parameter refers to the variable that is defined as part of the function definition. Argument refers to the value that gets passed into the parameter when we call the function. Let's talk about output from a function. Output from a function is called as return value. An example here would be result, which is being returned from the function. Let's talk about default arguments. You can use default arguments to put in default values inside a particular parameter. For example, let's say that you want to pass some default value into param2 here. We are going to cover examples of default arguments in the next lecture. The final terminology which I want to introduce is named keyword argument. When you pass your arguments, there are a couple of ways for you to send information. First way is by just directly passing the argument value, which would be the case when you have arg1 passed into param1. The second way would be for you to use the named keyword argument and say param1 equal to arg1. Notice the difference between the two. The previous example just said arg1. The current example says param1 equal to arg1. When you don't use the named keyword argument, you're passing something which is called as positional argument. We are going to be talking about positional argument in the next couple of lectures. When it comes to return value from a function, you can do a couple of things with it. You can either display the return value to a screen, or capture that into a variable, or do nothing with it. When you do nothing with the return value, after your program execution completes, the return value will simply vanish. Until your program executes, the return value will stay in the RAM, which is the volatile memory. Let's go through a couple of examples of calling or invoking function in Python. You should be familiar with both of these functions. The first example is for the print function, and the second example is for the f function, which we just went through. Whenever you are calling the function, you should always have the function name, and you should always have parentheses after the function name. Even if you don't have any arguments at all for the function, you should still use the parentheses. This is something which throws off a lot of new programmers. Just the function name by itself has a separate meaning in Python. Eventually, we'll be learning about that. But for now, you need to understand that even if there are no arguments to a function, you need to always use the parenthesis after the function name. Sometimes the function can have one or more arguments. When you have more than one argument, the arguments will be separated by a comma. Sometimes a function might have a return value which will produce some sort of a result from the function. Another example of the print function call here, which has two different arguments. Notice the comma in between both of those. That's going to be the separator in between arguments whenever you're making function call. Let's go through quick demo of the functions which we have already learned so far. We have covered the print function, so let's try to invoke the print function. I'm going to say hello/n world. Recall that /n represents new line. Print function will take the new line special character and apply it as a new line before it displays the rest of the string for you. Recall that we went through len function, which will enable us to compute the length of a given string. So I'm going to say len of Meena, which will produce 5 as the output. Another function which we have gone through is the type function. Recall that type function produces the type of a particular literal. Type of 1 is integer and type of 1.0 is going to be float. Type of string 1 is going to be string and type of true is going to be bool. You can always capture the return value from a function into a variable. You can say t equal to type of 1 equal to 1.0. So instead of displaying the return value onto the screen, it's now going to go into the variable t. So I can call the print function by passing t as argument. Notice that the display is slightly different now, but it still says that the type of this particular expression here is a boolean. Let me repeat just the type function call here. Notice that you're getting bool. For now, don't worry about the difference that you're observing here. You can directly call one function inside another function. For instance, I can say print of type function here. What will happen then is Python will execute this inner function call and it will replace the function call with the return value. So you're now going to get print of bool, which is going to give you the same display as in cell number 21 here. Let me give you example of typecasting. Recall that I briefly mentioned typecasting as part of the previous lecture demo. Typecasting functions enable you to convert one type into another. For instance, I can say str of false, which will convert the boolean value into a string type. And I can say int of false, which is going to convert the boolean value into an integer. And I can say str of int of false, which is going to first of all convert the boolean value into an integer, and then it will convert that integer into a string. I'm sure that all of you are used to performing computation using Python by now. Let's go through an example expression here where I'm saying 2 plus 3 into 4. It's very easy for you to identify the operator precedence ordering if you're familiar with it here. Let's say that you want to take this expression here and make it more readable for users by using functions instead of directly using the operators. Please note that the following demo will work for you only if you have downloaded guess.py as part of today's lecture code link. I've already defined functions for addition and multiplication inside guess.py. So if you're simply following along with this lecture demo, this particular example will not work for you. So I'm going to say add 2 comma and I'm going to say multiply 3 comma 4, which is going to produce the same output here. Just to reiterate, I've defined the functions for multiplication, which is mult, and addition, which is add here as part of guess.py. I'll wrap up this video here. In the next video, we'll go through demos.